Sure. Uh, Thanks a lot, Jing, and good morning and good afternoon, everyone. I'm Gokhul Srinivasan. I'm a senior partner solution architect at AWS, supporting our healthcare and life sciences global startups. And as part of today's session, we will go over the cloud migration, specifically for the bioinformatics and the life sciences organization. What sort of challenges they are facing, what are the drivers, and how our partner members help the entire process make more seamless and easy for the research scientist. So with that overview, so let's get started with an introduction about what exactly the driver for the life sciences in AWS and what the high performance computing for the life sciences in AWS looks like. In AWS, according to us, the overall concept of high performance computing may be complex, but it is our responsibility to make it easier and simple to describe and adopt. And as a philosophy, what we are looking at is we want to make the, the people who use the high performance computing to have an experience that the adoption of the high performance computing and developing solution using complex computing networks a lot more easier and simple, just like the way they adopt any other application. So this essentially should lead to more productive research scientists and research engineers, and making that compute capability available as and when they need it becomes an important part of the overall journey with regard to the high performance computing capabilities. And through AWS, our customers who wants to migrate to the AWS cloud and adopt these advanced computing capability, AWS helps them in a couple of ways. And the key aspect to highlight here is, hey, they can get access to the high performance computing and the complex computing network on demand without the hassle of the procurement. So it becomes a lot more easier, avoiding all the complex procurement channels. The second aspect is having the variety of options depending upon their exact computing needs. So that is not like a one size fit model. So each and every research process, every genomic and the clinical trial process is very different, requiring different type of capabilities. So having that flexibility to choose the compute needs becomes the second most important driver. And the third aspect is the cost effectiveness, because a lot of these research is not an extremely long-term research that requires a 24/7 computing operation. So the customer should have a significant amount of flexibility with regard to their investment. So by adopting AWS, one of the key capability or advantage is the elimination of the capex. So they do not have to have any upfront investment, but rather they can adopt the pay as you go model. So they end up spending only for the solutions and the services they use. So with this capability, we will look into how exactly the computing capability is brought into the hands of the research scientist, and what are the use cases that these high performance computing and the industry solutions can solve. So with AWS, as users, you have access to over 500 different type of instances that enables the customers to virtually run any workload of their choice. And AWS offers these different instances and constantly upgrade them. So the users who choose a specific type of compute instance are not fixated as a long-term commitment for that particular instance. They have the flexibility to improve, adapt, and over the time, experiment with the different compute capabilities that is offered as part of the AWS EC2 suite. And with over 500 different type of instances, the customers have the flexibility to choose based on the compute, where they can choose from half a processor to up to 96 processor within a single instance. And on the memory side, AWS provides the flexibility to choose memory from a few megabytes, few hundred megabytes, to up to dozens of terabytes. And coming on to the network, AWS computing capability can support the network connectivity from few gigabytes to up to 400 gigabytes, which becomes a lot more important, especially when it comes to the industry-specific solutions in life sciences, like a genomic research or a complex computation model. And these capabilities are the one that acts as a driver behind the scenes for a lot of research and development activities. And With that, we will look into, okay, there are different options, how exactly the customer chooses and what's the flexibility that AWS offers with regard to these computation capability. So Jing, if you can move to the next slide. Yeah. So no matter the type of workload and the quantity of research that your organization is doing, AWS offers a wide variety of compute capability that helps you maximize the performance and also provides you a flexible option with various different pricing model that puts the financial and the budgetary control at your hands. So while the AWS compute capability provides the flexibility in form of performance, the customer have the liberty to choose what type of compute capability they need, what sort of memory optimization are required, the clock time, as well as the graphical usage, the GPU usages for their specific workload. And while these flexibility comes in the form of the technical abilities, the customer have a variety of flexible pricing model to optimize their cost. And the key flexible model when it comes to the compute instances, the most common one is an on-demand, which is used for, which is, as the name suggests, it's an on-demand instance where the users can create the EC2 instances based on their compute needs, and they end up paying for the actual compute they use. And this does not require any long-term commitments, but the cost of on-demand instance in comparison with other pricing model is relatively higher. And then comes in the strategic savings plan model and the reserved instances. And thereby, the customer can choose the long-term commitment, can define their commitment window, and also indicate what sort of cost commitments that they wanted to bring in. While reserved instance helps customer reserve a specific instance for a specific duration, maybe a month, maybe even years. The savings plan provides the savings bundle option through the cost commitment. So there is a cost commitment as or the compute commitment based on which the customer can choose these model. And based on these model, they can realize up to 72% cost savings of the compute in comparison with the on-demand services. And finally, we also have a spot instance, which provides the flexibility that comes via the on-demand, but also realize the cost saving that comes via the savings plan or the reserved instances. However, the challenge with the spot instance is the guaranteed availability. As the name indicates, it is like an auction-based mechanism. So where the customers can choose the spot instance, but based on the supply and demand. And the availability of the spot instance, uh, based on the supply and demand, AWS can revoke the access to that spot instance within a couple of minutes based on the supply and demand that others are requesting. So while the spot instance provides a great flexibility when it comes to the pricing and also offers the high performance computing capability, the guaranteed availability is essentially where the concerns of the customer comes in, where they wanted the ability of the spot instance from a pricing perspective and the compute perspective, but they also require a consistent operating capability, like a guaranteed availability for their processing. And this is essentially where we will look into now the compute capability has been provisioned. How exactly the life science customers are using this? What sort of challenges they face, even with so many options? So it's not the lack of availability, but there is a lot of availability with regard to the computing size as well as the pricing. But still, the life sciences have a certain amount of challenges and barriers in adopting and modernizing these cloud-based technology. So, Jean, we can move to the next one. Yeah. So when we look into the challenges that the life sciences industry is facing when it comes to the cloud computing adoption, let's begin with the type of activity that happens in the life sciences industry. So the research and development activity, unlike a traditional industry application development or implementation, carries a lot of uncertainty where, to begin with, the workloads require extremely high performance computing and high network bandwidth for seamless communication. However, the processing capabilities are extremely expensive. So if they go with an on-demand compute instance, the predictability is uncertain. So they cannot really say for how long they need this compute and how much computing they need. So they certainly cannot go with on-demand. At the same time, a lot of these commitments, it's uncertain. So the savings that comes via the different options like the savings plan or the instance reservation, the reserved instances, can also prove to be expensive. The second aspect comes in the form of the sizing and the capacity needs. The workload spread across multiple tasks, even involving software and the services provided by different applications. And with each task comprising of multiple threads, the capacity can be significantly different for each and every processes, each and every task. So determining and boxing a specific capacity becomes even more challenging. So in a nutshell, a typical life sciences organization starts with no visibility on their compute capacity, cannot define the duration the research is going to happen, and also the number of iterations. It's not guaranteed like the workload completes, it's going to yield the expected result. So most of these research go as multiple iterations based on a feedback mechanism. So though the capacities do exist, in order to achieve a cost-effective operation, there is a lot of control that needs to be executed, and the uncertainty is significantly higher compared to any other industry. And it is just not the uncertainty. We will also look into what exactly are the typical barriers that these industries face when it comes to the life science adoption in the cloud. Ajing, let's move to the next one. Yeah. So now we saw around, hey, what are all the different capabilities that exist in the form of compute options, and what sort of challenges the life sciences industry face with a typical cloud adoption. But more than these capacities, there are key barriers when it comes, even if the funding is available, that prevents the life sciences industry to take the full advantage of the cloud computing. The first foremost thing is the research scientists in the life sciences organization who conduct the bioinformatics research or a genomic or a clinical trial research, they are highly skilled research scientists who are not design engineers. They are not familiar with the computing, the networking, and the infrastructure management that AWS and other cloud providers bring to place. So what it means is their focus needs to be more on the drug research, the life sciences research, and not focus on the computing and the engineering integration, where they provision the compute and make the compute systems available and communicate with each other. And oftentimes what happens or what leads to this is they end up over provisioning because they cannot gauge the right compute size. They over provision the compute resources with a significant amount of idle compute time. And on average, this could even be around 70 to 80% of idle compute time. And the reason for this being is that the task and the threads, they go in concurrent and the sequential manner. And there are a lot of dependency processes involved as well. And each of these processes, because of the uncertainty that we spoke in the earlier segments, that uncertainty leads to a reasonable amount of over provisioning, which results in higher cost of operations. And then these research engineers dependent on the data scientists and the research scientists, which even slows things down. So even with the option, the life sciences organization need to engage multiple resources, which acts as a barrier and also increases in the cost because of the multiple and multitude technology that comes into the picture. So that's essentially where AWS and our partners suite brings in the value added solution. And we will look into how Memverge acts as a unique player, simplifying all these challenges and the barriers specifically within the life sciences industry. So as we saw in the earlier sections, though there are variety of options available, it requires a lot of engineering and coordination and determination to find out the right capacity and the right duration of execution. And even with spot instances and the variety of compute pricing option, there is uncertainty with regard to the right balance that is needed. And that's exactly where our partner Memverge abstracts the overall decision making with regard to the AWS compute management and simplifies the overall cloud operation for the research scientists. And how Memverge does this is it offers a continuous operation at a lower cost, taking advantage of the spot instances and other flexible option plan. At the same time, ensuring that there is a continuous operation or there is no disruption with the overall research and the computing process. And this helps the life sciences organization in few ways. The first one, it eliminates the need for niche cloud computing resources in the form of cloud governance, provisioning, and operation, and also provides the flexibility in the hands of the research scientist through the managed service offering via the Memberge platform. And in addition, the Memberge user interface and the CLI makes it a lot more easier to deploy and operate these complex genomics and the life science research containers within the Memberge platform, which behind the scenes abstracts the usage of the EC2 compute needs. And Memberge, being a part of the global startup partnership, has the benefit that AWS brings to our customer through the availability of the latest and the niche technology, the provisioning becoming a launch partner where Memberge can be ahead of the curve compared to everyone else through the partnership advantage that AWS brings to the table. And in addition, whenever a new customer wants to adopt and get started with Memberge, they're also listed in the AWS marketplace, which becomes a lot more easier from a procurement perspective to subscribe to the Memberge product. And once the procurement is complete, the entire AWS experience is abstracted via the Memberge platform, making it easier for the life sciences research scientists to get started with the research activity and not essentially their the four-folk engineering related capabilities.